teachers, because even if after I show you this in a month, you're going to be like, oh, I remember this. But it's not something we like practice. We're going to take a day and maybe part of tomorrow to like review it, but then it just kind of seeps into questions as the year goes on. So as we're doing limits, derivatives, integrals, everything, there's just trig involved. And the same thing with e's and logs and natural logs. They love e's, natural logs. They love trig because those are hard. So their job is to separate a bunch of really smart people into categories, and the way you do that is to make tests hard. So this is just kind of review for your benefit. We're not really going to have like a trig chapter and a trig test. It's just basically one day of trig. So I'm going to draw the unit circle, and then we'll start talking about how I think about them and practice the problems. Wait, no. Don't even draw the circle. It makes it like goofy proportion-wise. I'm sorry. This is not to scale, because these are not evenly spaced, which is why it's weird to draw a circle, or hard for me to draw a circle. So there's a pattern with tick marks, and if you just remember the pattern, you can label this. So it's really this. It's really the square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. But 3 of those reduce. So, like, what's the square root of 0 over 2? 0. It's 0. Square root of 1 over 2. 1 half. These next two don't. The square root of 4 over 2 is 1, right? So, I think a lot of you can probably just remember that pattern, but if you can't, this pattern is a little easier to remember, and then you can just jump to, oh yeah, well, those reduce, so I can just kind of jump to that next step, whether you do that in your head or on paper or whatever. And then you label the tick marks in all 4 directions with those values. And then I'm just labeling X and Y values now. So I'm not, once I have this, I don't have to worry about, like, does Mr. Porter still do like the John Travolta thing? Like tangents positive here and here, and like windshield wipers for sine. And you guys are not Porter freak out, did you? Never mind. He probably still does, yeah. But this way you don't have to remember which quadrants sine is positive in, which quadrants cosine is positive in, because you're just looking at values. And then our dots, so this is a point here, then connect like the 1/2 and the square root of 3 over 2, make a dot, and then the square root of 2 over 2 and the square root of 2, make a dot. So like it's going to end up looking like a diamond, but that's because these are not really evenly spaced, it's just the way we drew it. But you see what I'm doing? It's kind of like a grid. You're connecting these points. And the same thing all the way around. A lot of people just, the first thing they do when they get a test is put this on. You don't get a cheat sheet, right? But you can, as soon as you get your test, flip it over to the back and draw this. And that's, you just created a cheat sheet for you to use during the test. And then you got to be able to label the numbers too. So the middle ones, like this one, and then the axis, and then this one. So does that make any sense? So this one and this. So this is 0, right? And if you skip a dot and go to the next one, that's 45. Skip a dot, go to the next one, that's 45 more. Skip a dot, go to the next one, that's 45 more. Skip a dot, go to the next one, that's 45 more. See what I'm doing there? Then keep going around. Skip a dot, go to the next one, so it'll be 225, 270, then you get back to 360, which is 0, you know? No, why not add? No, you can put there. Yeah. I don't know if it's going to move very well.
Yeah, why'd you move it?
You can move it back up.
There's stuff up there. Whoa, you look so young.
What I just heard was, wow, you're freaking old.
I'm just moving your keyboard.
That's fine.
Brittany, can you see this?
As long as you're comfortable, Travis, that's all I.
Is that what you
Ah!
Is this gonna fall?
I wasn't gonna fall over.
It just fell. Yes.
If it falls, I'll run over there and catch it. Yeah.
It's you're basing the fate of the computer on your running skills.
It's already basing the fate of it on his, like, balancing thinking.
I think it looks fine.
Okay.
We can continue.
Alright, so then the other dots are 30 apart, so you kind of ignore the 45, the ones that we just did. This goes 30, 60, 90, 120, 150. So then you build around the ones that we already had by adding 30 each time. So 0 goes to 30, 30 goes to 60, 60 goes to 90, we already know that one. 120, skip the 45s that we already did. See what I'm doing here? So then 210, 40, 300, 350. So this is the unit circle, although mine looks much more like a diamond. Because these are not really evenly spaced. It's just easier to read the grid if we make them that way. And then, everything you need is right on that chart. Those are all just coordinates. So, what you need to know then is what does cosine mean, what does sine mean, and what does tangent mean. So what do you look for if I ask you to find cosine? Cosine is the x value. Sine is the y value. I got my fancy spelling trick there again. Spell sine with a y. I hope you remember. I hate that so much.
Yeah.
Yes.
Well, then don't freaking write it.
I'm not writing it.
I'm going to write this problem on the board for maximum anger. Just the limit will bother you too, I think. Yeah. And then what's tangent? Tangent is y over x, or you can think of it as sine over cosine. I'll write it with the y this time. Some people will have. And then, does it really bother you that much?
It's so annoying.
You're going to be in college one day, like, what's the limit? What sine is the y's or x's? Oh, yeah, Mr. Davis spelled it weird. That's going to help.
Maybe I'll accidentally start spelling it wrong.
Mr. Packard yells.
Yeah.
Why would whoever you sign
Okay,
in
and
a
then-
Packard paper? Limit.
Sin, yeah.
Sid.
So, this is not like proper mathematical notation, but I'm going to do it anyways. Cosine is secant flipped over. So another way to write that would say cosine, or secant equals 1 over cosine. If you want to write it that way. This seems to like help most people kind of see it better, so that's what I'm going with. You can write whatever you want. If you want to write secant equals 1 over cosine, do it that way. But cosine and secant are reciprocals. Sine and cosecant are reciprocals. Which is annoying. Like it'd be nice if they were the same letter, like cosine flipped over to cosecant, but that's not how it works. And then tangent and cotangent are reciprocals. fact you need to do basically any trig problem is, let me show you why this happens too. How many degrees is it to get all the way around the circle? What is the circumference of a circle with, okay, let me back up. What's the radius of this circle that we drew even though it's that? 1. So what's the circumference of the circle? 2 pi r, so 2 pi, right? So it's not magic where they just define like, hey, pi radians is going to be 180 degrees. It's because if you go around the outside of the circle, that's 2 pi radians that you just went around. If you go around the inside of the circle and think about it in degrees that you're spinning, it's 360. So then 180 degrees is equal to pi radians. And if you have this information here, you should be able to do any of the trig problems that you need. So let me write a couple on the board. We'll kind of talk through how to think about it. So let's say, okay, we'll start simple. So let's say it was cosine of 210. So you're finding 210, and you are taking which value? Taking the x value. So 210's here. This is your x-axis. So you just go up to the x-axis, and that would be negative square root of 3 over 2. And ideally, you get to the point where you can kind of do this in your head, like without drawing it. You can kind of visualize. Okay, 210 would be like 3 tick marks that way. Okay, that's negative square root of 3 over 2. And that may or may not happen for some of you, and that's okay if it doesn't. It's kind of like the best case scenario, I suppose. Let's say sine of 225. And then I'll start throwing it as well. We'll do one more. So if you can, try to do it without look at it first. And then if you get stuck, obviously look at it. But the goal is that you don't necessarily need it. So 225 is going to be in the third quadrant. So it's between 180 and 270. It's right in between those. So it's that 45-degree angle. And I want the y value, which is going to be negative square root of 2 over 2. Let's say tangent of 270. Again, try to do it without looking. If you can't, especially right now, that's okay. So you want the y value divided by the x value. So 270 is down here. What's the y value? So this coordinate is really 0, negative 1, right? So the y value is negative 1. The x value is 0, so what would you say? Undefined. So little tricks they can start adding. So I can say like sine of negative 330. Does not mean sine minus 330. That wouldn't even mean anything. So in my opinion, they should put parentheses there every time, but they don't always. So you just got to kind of know what it means. And what does the negative tell you to do? You go the other way, or some people prefer this. This is too small. My circle only works between 0 and 360. This doesn't work. It's too small. Add 360 to it until it gets into the numbers that we like. So if I add 360 to this, what do I get? 30. So this is the exact same question as sine of 30. And you can get to that either by taking this and adding 360, or going 330 degrees backwards. Then when you get there, you're taking the y value, which is a half. That's another thing people will use. Like if you remember this fact, sine of 30 is a half. That to me is like a really good starting point for anything else. If you could just start with sine of 30 as a half, you can and you have some idea what's going on, you can pretty much work your way around anything from there. Just another way to think about it that some people do. Let's say, alright, so let's start flipping them. Let's say cosecant of 135. Try that. So 135 is the second quadrant. So we're right up here. Cosecant is which one flipped over? The sine flipped over, so I want the y value. And then I want to take that y value and flip it upside down. So this is 2 over root 2. If it's free response, I want you to leave it like that. Because you have nothing to gain by simplifying. The only thing that happens is you might screw it up. And this is correct, so you can stop. If it's multiple choice, though, they're probably going to rationalize it. So just to remind you what you're doing there, you multiply by the square root, wherever that was, and then what's root 2 times root 2? And then, did someone just say 3? And then 2 times root 2 on top, and those would cancel, so this is actually just root 2. But these are both acceptable answers, it just depends on, their format. Yeah.
So, what I did was originally I put 1 over 2 root 2.
Okay. That's fine.
That's fine.
And then you gotta so you could leave it like that if it's free response.
Yeah.
If it's multiple choice, remember
Multiple choice has simplify.
do you know how to simplify?
Yeah.
Then yeah, that works.
Okay.
I think this is a little easier, kind of saves you stuff,
Yeah.
but you can do whichever,
Yeah, I just brain farted.
No, you're good. Let's say cotan of negative 150. And again, I put the parentheses there because I think it's way easier to read. They might not. So just realize that. So negative 150, you can go 150 backwards, or you could add 360 and say, okay, that's really the cotan of 210. And then tangent, cotangent's which one flipped over? It's tangent, right? So tangent's y over x. We want the flipped over version of that, so we want x over y. So I want my x value, which is negative root 3 over 2, divided by my y value, which is negative 1/2. Free response, stop. You have nothing to gain by continuing. You only have potential to screw it up and lose. But these would just cancel, the 2's. You got like a 2 on the bottom of both fractions. The negatives would just cancel, and this really just comes out to be the square root of 3. But if you had it like that in the free response, that'd be totally right. They would not leave it like that in multiple choice. How many had root 3? Okay. Let's say tangent of 810. Yeah, we checked the tests a lot faster than I thought it was. Moving on. There's a video. No calculators.
Don't do it in your head.
No, she said that. Oh my god.
It's probably easier to subtract 720 than it is to subtract 360 twice.
You know what?
Maybe that would have been helpful 30 seconds ago. I don't know.
That's not even possible. Yeah, I know, I'm lost.
If you're doing the subtraction so you don't get a number that's on the unit circle, you did something wrong.
Oh, wow.
I know I did something wrong. Oh, yeah, that's stupid. Okay.
So if I subtract 360 once, it gets me to 450. If I subtract 360 again, it gets me to 90. I got 5 minutes left to do radians too, so I gotta go. So tan of 90 is the y value divided by the x value at 90. So what's the coordinate of that point? One's not
Sorry,
coordinate.
I didn't.
0, 1, and then so y value over x value would be 0. 1 over 0, which would be undefined. How many had undefined? If you didn't get it, was the problem the trig or was it literally the subtraction?
The subtraction. I actually get that fast enough.
So you could do it, you just needed like a little more time.
Yeah.
Alright, let's say cosecant of 11 pi over 6. So I just want to show you like a way to make your math easier here. First of all, pi is how many degrees. Nobody that I know thinks in terms of radians. And maybe someone in here does, I don't know. But I always flip it to degrees first. And then I do the problem. So I'm going to plug in 180 in place of pi. And now you got two options. You could do 11 times 180. Get some gigantic number. And then divide it by 6. But that's a pain. It's way easier if you make the number smaller first. So what's 180 divided by 6? Like, just worry about that part. What's that? 30. Then what's 30 times 11? 330. If you did that first, now you're at 1980. 1980 divided by 6. That's just way harder to do the mental math that way. So make it smaller first, and then go from there. Then we gotta do the problem still, right? Is it 11:02? Is that my deadline?
Yeah.
So then 330, it's like 1 tick mark down and 3 to the right, so we're over here. Cosecant's which one flipped over? Sine, so sine's the y value, so -1/2, but I want to flip that over. So how many have -2 there? I know I'm going pretty fast. Hopefully it's okay because you've seen it before, but I also understand you don't remember it. Other questions I can answer right now? It's even okay. Let's do one more of those radian ones. Let's say secant of 7 pi over 4. Remember, divide first and then multiply. It makes your life a lot easier. So, shove 180 in for pi. And again, I'm not going to do 7 times 180 and then divide by 4. I'm going to do 180 divided by 4. So what's half of 180? 90. And then what's half of that? 45. And then I got to do 7 times 45. So if you get stuck, like I'm not even going to do the multiplication. I'm going to go, that's 1, 2, 3, 4, 5, 6, 7, 45. So I'm just counting. So that's 315. Secant is which one flipped over? Cosine. So I want the x value here, but upside down. So 2 over root 2. And that's a perfectly legitimate answer, as it is. If you rationalized it, that would just be root 2. Questions? So that's due tomorrow.
It was just on the table. I was like, I'm gonna put
Are you turning it in? Turn it in. I can tell you if you're right now. Nah. You're gonna talk to you.
Yeah.
What you're doing.
We do.
So in my head, I'm like, just turn it in, just turn it in.
I was so. Oh my gosh. I was like, I know it.
So, here, I'll show you why.
This,
If you know why.
but-
So, like, these are two roads. So, there's both there's both circular.
Is that even? Yeah. We get a break. That makes sense. Oh, yeah. Thank you.
Yeah.
Where this
Brother came up
Sheila, when do you think you're
tomorrow.
tomorrow?
For the test?
Yeah.
If it's similar to that,
I don't know.
if not, Thursday's fine too. We'll do it Thursday.
I don't.
Yeah, Thursday.
Thursday? Okay.
I'm sorry.
I don't have it yet, Rachel, but I will.
Okay.
And don't be afraid to remind me. Like, if you're not nagging me, if you're reminding
Okay.
me. I told you I'd do it, so. Yeah.
Good.
Love you.
Good time.
I know. Thank you.
See you, man.
See ya. Did it go okay, or was it bad as you thought?
I don't know. There was some really stupid mistakes that I've made while grading it that I realized. But I don't know. Do you know if there's gonna be corrections or?
I don't know. It kind of depends on the class I have.